early days of programming, programmers would use punch cards to communicate with the computer. The system they used was called the binary number system or the base 2 system. This system is very similar to Morse code, where there were only two symbols in the system. In Morse code, you had the dot and the dash, and using the dot and the dash, you could represent multiple numbers and symbols. With the binary number system, holes were punched in the card to either let the electricity flow through or prevent the electricity from flowing through. Think of a switch being cut on or off. If the switch was on, the electricity flows. If the switch is off, the electricity does not flow. Ones and zeros were used to represent this state. Computer programmers developed something called the ASCII table. For every letter and number and symbol that could be represented, there was a particular series of ones and zeros that would actually represent that letter or number. These ones and zeros, these binary numbers, had a direct formulation or translation to decimal numbers. This video is all about the relationship between those numbers, keeping in mind that to program the computer, a programmer would have to figure out which letter they were going to use, for instance, the G here. See that the letter G is represented by the number 71, and then convert that 71 into a bunch of zeros and ones, or what we call a binary number. In essence, all of these things just represent symbols that we use to communicate with each other. We are no stranger to using symbols. Each civilization had their own unique set of symbols to represent things like numbers. I can imagine the earlier human beings use slashes to represent some magnitude or some quantity of something. Even today, basketball coaches use these same slashes to keep track of a player's foul shots or fouls. We know that if we see a group of slashes like this with a diagonal slash, that represents 5. So if we saw 8 of them, we wouldn't sit there and count each slash. We would know that that group of 8 represented the number 40. Throughout civilizations, they have used different symbols. The Greeks, the Romans, the Chinese all had their own symbol system to represent numbers and letters. We have adopted something called the Hindu-Arabic system. The Hindu-Arabic system uses 10 symbols. We call this the decimal system or the base 10 system. Now, we are so familiar with this that when we see the symbol 3, 5, and 7, we know that's 357. But how actually do we get to this number? It turns out that for each one of these symbols or digits, it is a representation of a number multiplied by the base 10 to a certain power. So for instance, the one that is the rightmost is always multiplied by 10 to the 0th power, or 10 to the 0th power is 1, so it's multiplied by 1. As we move out or extrapolate out, we see that the second digit is multiplied by 10 to the 1st power, and the third digit 10 to the 2nd power, and so on and so on. When we look at 10 to the 2nd power, we know that's 100. So this digit is multiplied by 100. 3 times 100 is 300. If we add all of these up, we come back to the original number, 357. But this is no news to us because we can look at this number system and always tell what magnitude or quantity is being conveyed. When we look at the binary number system, it is based on two symbols, 0 and 1. 0 being the switch is off, 1 being the switch is on, just like the punch card that we saw earlier. So when we're looking at a symbol that looks like this, 1101, we are not looking at something in the base 10, in which this would be 1101, but we're looking at a totally different representation altogether. Since we are working in the base 2, we would then figure out the decimal equivalent of this number, the next segment in this video will show you how to convert from a binary number to a decimal number.
Hi, I'm Abigail Bornstein, and this is part 2 of the video on binary. In this part, I'm going to cover how to go from binary to decimal. So as you can see up on the board, I have the number, or the binary, 00110010. And binary is usually written as a byte of information, so I have, which is a bit, 8 bits, so I have 8 bits up here. And the way that you start, as soon as you get a byte of information, is that you have to put the numbers underneath, which are 1, 2, 4, 8, 16, 32, 64, 128. Now, where did I come up with these numbers? Again, it has to do with the fact that binary is by, or 2, base 2. So you always work the base number of 2 and you raise it to the power. 2 to the 0 is 1. 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, etc., until you get to 2 to the 7th, which is 128. Okay, so it's okay if you don't completely get the whole base 2 idea, but it's important that you know that you always write 1, 2, 4, 8, 16, 32, 64, 128. In that order. All right, now I want to know what in the world is this number, or this decimal equivalent. So all I have to do is, first of all, I'm going to clear this away so we have room to work. Is anywhere where there is a number 1, I will bring down that number. So I have a 1 under 32, so I bring down 32. I have a 1 under 16, so I bring down 16. And I have a 1 under the 2, so I bring down the 2. Then all I need to do is add these numbers together, and the result is, if you add this up, you'll find that the number is 50. And that's all there is to writing the decimal, the binary to decimal. Okay, let's do another one. All right, I've got 111000101. So again, wherever I have a 1, I bring down the number. So I've got a 1 under 128. I have a 1 under 64. I have a 1 under 32. I have a 1 under 4. And I have a 1 under 1. And I take each one of these numbers and I add them up. And that gives me 229. So what would be the absolute highest number that we could write if we had a byte of data? Well, in that case, that would mean that I have a 1, 1, 1, 1, 1, 1, 1, 1. And if we were to add all of these numbers together, that would equal 255. So if I went from 0 to 255, that would actually give me 256 possibilities. So good luck converting your numbers. Hi, I'm Abigail Bornstein, and today I'm here to talk about binary, converting from decimal to binary. So as you know, binary we represent using either 0 or 1, and we usually write binary a byte at a time, which is actually 8 bits. So I'm going to start with 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. And I want to write the number 54 in binary. So starting over from the right, I will put the number 1, 2, 4, 8, 16, 32, 64, 128. Okay, so now let's see how we can write 54 in binary. Starting with the 128, can 128 fit inside of the number 54? No, it can't, so therefore you would write a 0. Then you move to the next number, 64. Can the number 64 fit inside of the number 54? Once again, no, so it gets a 0. Can 32 fit inside of the number 54? Yes, it can. So therefore, you would place a 1. You would then come over to the 54 and subtract your 32. That gives you 22. Okay, so now I'm working with the number 22. Over here, number 16. Can 16 fit inside of the number 22? Yes, it can, so it gets a 1. I come over here, I subtract the 16, which hopefully is 6. Then I come back over to the 8. Can the number 8 fit inside of 6? No, it cannot. So I write a 0. Then number 4. Can the 4 fit inside of 6? Yes, it can. So I get a 1. I subtract out the 4. That leaves me 2. I come over to the 2. Can 2 fit inside of 2? Yes, it can. So I write a 1. I come over here, subtract the 2. Gives me 0. Does 1 fit inside of 0? And the answer is no. Okay? So here we have the number 54 written in binary, which is 00110110. Let's do another one. I've left the same structure that I had up on the board before, and this time we're going to work with the number 188. So I want to write the number 188 in binary. So again, I have my byte of information, which is 8 bits. I have the 1, 2, 4, 8, 16, 32, 64, 128. Now I start with the 128 and I say, does 128, this number, can it fit inside of 188? And the answer is yes, so it gets a 1. I then would subtract the 128. That leaves me with 60. Then I come back to 64. Does the number 64 fit inside of 60? No, it doesn't, so it gets a 0. 32. Does the number 32 fit inside of 60? Yes, it does, so it gets a 1. And I subtract 32. And hopefully, if I do my math correctly, that's 28. Then I come to 16. Does 16 fit inside of the number 28? It does. So I put a 1, and then I subtract the 16. That leaves me with 12. Does the number 8 fit inside of 12? It does. So I put a 1, and I come over here and subtract the 8. That leaves me with 4. Does the number 4 fit inside of the number 4? It does. So I place a 1. I come over here, subtract the 4, and I've got nothing left. So does 2 fit inside of 0? No, it doesn't. So it gets a 0. Does 1 fit inside of 0? No, it doesn't, so it gets a 0. So to write the number 128 in binary, it would be 10111100.
In this segment, we're going to talk about adding binary numbers. But before we add binary numbers, let's talk about how we would add decimal numbers. When we add decimal numbers, we start in the rightmost column by adding the 2 digits together. When we add them together, our result is a 2-digit number. But we don't write the 2 digits here like this. That would not make any sense. Instead, we write down the 1 digit and we carry the next digit to the next column. And if we added those numbers and it came out to be, again, a 2-digit result, we would write down the 1 digit, carry the next digit to the next column, and if there was nothing to add to it, we simply bring it down. In other words, when we add a series of numbers, if it turns out to be more than 1 digit, we carry the next digits over to the next column. This is important when we look at binary numbers. When adding binary numbers, you're going to get a quicker turnaround or turnover of those digits. If you can recall from the lesson on converting decimal numbers to binary, we have a little table over here that shows the binary equivalent of 1 is 1, the binary equivalent of 2 is 1, 0, the binary equivalent of 3 is 1, 1. So when we're adding binary numbers, if the result is 2, 2 is represented by 1, 0. If we look at this first problem right here, we're looking at 1 plus 1 is equal to 2. But in binary, we cannot write the number 2 as a result because this number must be represented in binary. So in order to write this answer down, we have to write it as the equivalent of 2, which is 10. So with a 2-digit number, we simply write the 0 and carry the 1 to the next column. So this would be 1 plus 1 plus 1 is 3. The binary equivalent of 3 is 1, 1. So I would write down the 1 and carry the other 1. Now this is where it gets a little tricky because the binary equivalent of 4 is really 1, 0, 0. So the way we do this is we write down the 0, write down the next 0 in the next column, and then write down the 1. So really we have 1, 0, 0, which is 4. Again, let's do that again. If the binary number is 4, we write down the 0, carry the other 0, and carry the 1. So really we're writing down 100 by putting 0, 0, 1. So this column, this is 2. A 2 is 1, 0, so I'm going to write down the 0 and carry the 1. Now I have 3 ones in this column. A 3 is 1, carry the 1. A 3 is 11, or 1, 1. 3 is 1, carry the 1. 2 is 10, so that's 0, carry the 1. 3 is 1, carry the 1. And here I have 1 plus 1 is 2, so I'm going to put down 0, carry the 1, but I'll just bring that 1 straight down. So this number is actually what the addition of all of these binary numbers turns out to be. Let's do another one. So over here I have 1 plus 1 is 0, carry the 1. Where do I get that? Because 1 plus 1 is 2. 2 is 1, 0. So I'm putting down a 0 and carrying the 1. 1 plus 1 is 1, carry the 1. 2 is 0, carry the 1. 3 is 1, carry the 1. 3 is 1, carry the 1. And that 1 just comes straight down in addition. Let's do one more. Let me change this one up just a little bit by putting a 1 here and a 1 there. So again, I'm looking at my table right there, and I say 1 plus 1 is 2, so that is 0, carry the 1. 1 plus 1 plus 1 is 3, that is 1, carry the 1. Well, that's 4. 4 is 0, carry the 0, carry the 1. And then 2 is 0, carry the 1. 4 is 0, carry the 0, carry the 1. 2 is 0, carry the 1. 3 is 1, and I bring the other one down, 1. There's my number. So just to be clear about this, if this number had been 5, let me just mark it up over here. If this number had been 5, it would be 1, carry the 0, carry the 1, because 5 is 101. So I would put down 1, carry the 0, carry the 1. This would be 1. That's 5 again, so that would be 1. Bring over the 0, bring over the 1, and there's my answer. This is how to add binary numbers. You will not be allowed to convert these to decimals and then add them and then convert them back. You must in fact do the binary arithmetic for these. In this segment, we're going to learn how to subtract binary numbers. But before we do that, let's talk about subtracting decimal numbers. In this case, we have 45 minus 28. We learned that when the top number is smaller than the bottom number, we can't subtract this. So what we need to do is borrow to help this number out. In this case, we borrow from the 4, making this a 3, and most of us simply just put a 1 there and we understand that this number is now 15. But what is really happening right here? What's really happening is when we borrow from this column, we're actually carrying over 10. So we understand that this is 10 plus 5, which is 15, which allows us to get 7 in the subtraction. Why do we get the 10 here? Because we're in the base 10. So this represents the actual base. That's important later, okay? We're carrying over 10. Now, in this case right here, we want to borrow, but the next digit over doesn't have anything we can borrow from. So what we do is we borrow from the next column, making this again a 3, and this becomes 10 again. Now, in order to help this column out over here, this 5, we need to then borrow from it and make it a 9, and then this becomes the 10 or the 15 that we need to do the subtraction. This intermediate step, I don't bother with it. If you choose to do it, it's okay. But what I normally do is when I have a situation where I'm borrowing for more than a column over, I would simply make this a 2 and then make this a 9, a 9, a 9, and then the 10 over here or the 12 over here. Okay? So what I'm skipping is that intermediate step of making the 10, crossing it out, and making the 9. I just go 9, 9, 9 until I get back to the column that I'm borrowing for, and I make that column the 10. To do the subtraction for binary numbers, we see here that I cannot subtract 1 from 0, so I need to borrow. When I borrow from this digit right here, that becomes a 0. And again, normally we put the 1 right here. But what is 1, 0 in binary? 1, 0 in binary is actually 2. So instead of putting the 1 there or the 10 above, I simply write the symbol 2. Now, normally we don't want to use the symbol 2, but in this case it's okay because the result of this, 2 minus 1, will be again a binary number that we can live with. So it's okay to write the 2 above here, but it's not okay to write a 2 below in the results. So 0 minus 0 is 0. That's fine. Here, I can't do it. But because I'm borrowing from a column that's further over than one column, what I'm going to do is write down 1, 1, and then when I get back to the column that I'm borrowing for, I write a 2. If I didn't want to do that and do the intermediate steps, I would write down the 0, write down the 2, borrow from it, making it 1, write down the 2, borrow from it, making it a 1, and then write down the 2. I don't like to do those intermediate steps because I know it's going to result in 1. So what I do is I simply write down 1, 1, and when I get back to the column that I'm borrowing for, I write down 2. 2 minus 1 is 1, 1 minus 1, 1 minus 1. There's my answer right there. So let's do this next one. I'm borrowing from a column more than 1 over. So I'm going to borrow from it, and instead of writing 2, I'm going to write down 1, and then when I get back to the column that I'm borrowing for, I write down 2. 2 minus 1 is 1. 1 minus 1 is 0. Here I can't do this, so I need to borrow. The next column that I can borrow from is here, so I will borrow from here, and then I will write down 1, 1, and I'm back to the column that I'm borrowing for, so I write down the 2. 2 minus 1 is 1. 1 just simply comes down. 1 minus 1 is 0. 0 minus 0 is 0. Here I can't do it, but I'm right next door. So I'm going to cross this out and then put a 2 there because I'm right next door. 2 minus 1 is 1, and there's my answer. So again, when I'm right next door, I just write a 2. When I'm more than one door over, then I write down ones until I get back to that column. So in this case right here, I borrow, I make this a 0, I write down 1, and then I'm back to the column, I write down 2. 2 minus 1 is 1. 1 minus 1 is 0. Here I can't do it, so I go to this column, I write down 0, and then I write down 1, 1. I'm back to the column where I was borrowing for. I write down 2. 2 minus 1 is 1. 1 comes down. 1 minus 1 is 0. I can't do this one, so I need to borrow. Strike that out, write a 0. I write down 1. I'm back to the column. I write down 2. 2 minus 1 is 1. 1 minus 1 is 0. 0, 1. And there's my answer. So the key to this is, again, if I'm borrowing from more than one away, I want to just write down all ones until I get back to the column. If I'm borrowing from right next door, then I simply just, in this case, I simply just write down the 0 and carry the 2. This is subtraction. And again, this must be done with some method. You cannot convert these to decimal, subtract them, and then convert it back to binary. In this segment, we will cover multiplying binary numbers. But before we multiply binary numbers, let's look at multiplying decimal numbers. In this case, we have 32 times 12. Now, a method being taught in school now is to use boxes to do the multiplication. I do not use that method, and that method won't apply to the method that I'm going to show you when multiplying binary numbers. Instead, I use a traditional method where I'm simply going to multiply each digit by the top number. So the first thing I have here is 2 times 32. So I would say 2 times 2 is 4. 2 times 3 is 6. And then for the next digit, some of us like to put a placeholder right here just to keep things in line. And then you go here and go 1 times 2 is 2, and 1 times 3 is 3. Once you have multiplied by each digit, it then becomes addition again. So to add these numbers, it's 4, 8, and 3, which is my result. When I'm looking at a number like this, again, I start with each digit and multiply it by the top number. This would be 3 times 1, 3 times 2, and 3 times 3. Now for me, when I see this 0 right here, I don't see this as significant, so I simply skip it. Some students learn to simply put all zeros for that row. If you've learned that way and you like to put all zeros, by all means do so. What I do is skip that column and then go to the next column. Again, if you would like to put placeholders there, I then go 1 times 1, 1 times 2, 1 times 3, and now I'm back to addition again. So that's 3, 6, 10, 3, and 3. The only time that 0 holds some significance to me is when it is a 0 in this place. This 0 is significant, so I must put that 0 there. Again, but I simply just put the 0 there and not a bunch of filler zeros in a whole row. Once I put that 0 there, I then go to the next column and go 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, and then I go down to the next column. If you like to put fillers in there, the key is your multiplication or your result will start right under the column that you're multiplying. So 1 times 3, 1 times 2, 1 times 1, and then again it becomes all addition. The beauty of multiplying binary numbers is that you're always going to be multiplying by either 0 or 1. And 1 times any number is simply that number. So when I take each digit and multiply it by the top number, essentially all I'm doing is duplicating the top number. For me, again, this 0 is insignificant. I don't write it down. But if you like to, you can just put all zeros for this row. For me, again, just to have fillers in here, I put fillers in here, and then I go right under this column right here, and I simply write this number over again. So this number is 0, 1, 1, 1. And now I have nice, neat columns, and I'm ready to do my addition. Back to addition again. This is 0, 1, 1. 1 plus 1 is 2. 2 is 0, carry the 1. 2 is 0, carry the 1. 2 is 1, 0. And there's my number. And let's do this example right here. I'm right under this number. I simply duplicate the number that's on the top, trying to keep nice, neat columns. If you need a filler, put a filler in there. But again, I get right up under this number and I duplicate the number on the top. It's 1, 1, 0, 0, 1. This number right here is insignificant to me, so I'm just going to skip it. But again, to get over to this column, I'm going to put fillers in the back of this, and then right under this column, I'm going to start that number again. It's 1, 1, 0, 0, 1. And now it's all back to addition again. 1 plus 1 is 2. 2 carry the 1. 2 carry the 1. 2 carry the 1. That's 3. That's 1 carry the 1. Carry the 1, 1, and 1. And there's my number right there. So again, I'm just going to get right up under that number and duplicate the top number, because 1 times that top number is that number right there. Look at it. There's the number there. There's the number right there. It's right under the number that I'm multiplying. So as I said before in the other example, the 0 is significant here, so I need to put it in there and it's going to be significant. But for this other one right here, I'm going to go right into multiplying this times the top number. This top number is 0, 0, 1, 0, 1, 1. This top number is 0, 0, 1, 0, 1, 1. 0, 0, 1, 0, 1, 1. I put it right under the number that I'm multiplying. So again, this 0 is not significant to me, so I'm going to skip it and go to this next one. But in order to do this next one, I'm going to fill it in with all zeros, and then as I get up under this number, I'm going to write the number again. 0, 0, 1, 0, 1, 1. Once I do that, oh, bad line. It becomes all addition again. 0, 0, 0, 1, 0. 1 plus 1 is 2. That's 0, carry the 1. 0, carry the 1. 0, carry the 1. And there's my number. The thing that you have to do carefully with multiplication is make sure you line everything up nice and neatly. But because you're multiplying by 1, you're just rewriting the top number. And again, you have to be cognizant of where you can skip the zeros and where the zeros are significant. And it goes without saying that you cannot use a calculator. You cannot convert these to decimals, multiply them, and then convert it back to binary.